In this video, we'll discuss how to find the payment amount necessary to get a certain future value for an ordinary annuity. Now recall that the future value S of an ordinary annuity used to accumulate funds is given by this formula that the future value S is equal to the payment value R times the quantity 1 plus I, where I is the interest per period, raised to the n, where n is the number of periods, minus 1 divided by I. Now recall that the interest per period can be written as R over M, where R is the annual interest rate and M is the number of times compounded in 1 year. And that N is equal to M times T, where M again is the number of times compounded in 1 year times the number of years. So when you multiply those two together, you'll get the total number of compounding periods. Now for the problems that we're dealing with in this video, we're given everything except the payment amount, and we're trying to find out what is R. Now, so we could use this formula, and just plug in the values which we know. Also, you could take this formula and solve for R, which would just be by multiplying by the reciprocal of what's inside the brackets. And so R is equal to S times I over the quantity 1 plus I raised to the n minus 1. But if you just remember one formula, you have the other formula. Now for this example, you're given that a finance company recently offered an annuity that pays 6.35% compounded monthly. What equal monthly deposits should be made at the end of each month into this annuity in order to have $200,000 in 15 years? So we know the future value, and we want to find out the payment value, and we know it's an ordinary annuity because the payments are made at the end of each period, which in this case means at the end of each month. So we know our S is equal to 200,000, R is equal to 0.0635, T is 15, M is 12, which means that I is equal to the 0.063 divided by 12, and N is equal to 15 times 12, which would be 180. So all we got to do to figure out the payment amount is to plug these values into that formula. Now if you plug this onto your calculator, you get 670.431666. So the equal monthly deposit amount would be $667.43. Now if we wanted, we could figure out how much interest this person would earn with this annuity by figuring out, okay, what is the total amount that they would put in themselves, and then subtract that from the $200,000, because that all that extra would be interest. So you could take that $200,000 minus, well, they make 180 payments of $667.43, and if you subtract those, you get that the person would make $79,862.60 in interest with this annuity.